Hey there. Ready to dive into some online security today?
Always.
We're going to be unpacking this U.com research on how websites are protecting us from attacks.
Sounds interesting.
And get this, the really interesting part is that these attacks, they target you,
Oh.
not just the websites themselves.
I see where this is going.
So we'll see how that all works.
Yeah, let's get into it.
It's kind of like realizing that our browsers are secretly way more involved in security than we thought, right?
Yeah, it's a fascinating shift in cybersecurity.
But before we get into that, let's start with the basics.
Yeah.
What exactly IBES a client-side attack?
So imagine this.
Okay.
You're browsing the web, right?
Mm-hmm.
Clicking links, filling out forms, all the usual stuff.
Yep.
But lurking behind those seemingly harmless actions
Oh.
could be malicious code designed to exploit vulnerabilities in your browser.
Uh-oh.
And that's what we call a client-side attack.
It sounds a little unsettling.
Yeah.
So it's not like those old school hacker movies where they're trying to break into a mainframe.
Nope. This is happening right in our browsers.
Precisely.
Yeah.
And these attacks are becoming increasingly common because they exploit the trust we place in our browsers.
Oh, that makes sense.
We expect our browsers to keep us safe, but attackers are finding clever ways to turn that trust against us.
Okay, that's enough doom and gloom.
Right.
So the paper highlights three main types of client-side attacks.
Okay.
Let's break them down.
Sounds good.
First up, we have cross-site scripting.
XSS?
XSS, yeah. Can you give us a real-world example of how that works?
Picture this. You're reading a blog post and decide to leave a comment.
Okay.
But hidden within your words is some nasty code that can hijack someone else's account when they view the page.
Oh, no.
That's cross-site scripting in action.
Wow.
It can be pretty scary.
So, like, I could leave a comment that seems harmless, but secretly contains code that steals cookies or login credentials from other users?
Exactly. And it's not just limited to comment sections.
Attackers can inject malicious scripts into any part of a website that allows user-generated content,
Okay.
like forums, contact forms, or even social media platforms.
That's wild.
Yeah.
It makes you think twice about leaving comments anywhere.
Yeah, you got to be careful.
Okay, next up we have cross-site request forgery, or CSRF.
CSRF? Yep.
How is that different from XSS?
Well, while XSS injects malicious code,
Okay.
CSRF tricks your browser into performing actions you didn't intend
Okay.
on websites you're already logged into.
Gotcha.
So say you're logged into your bank and click a seemingly harmless link on another site. That link could contain a hidden request to transfer funds from your account.
No.
And because you're already logged in,
No.
the bank's website might process it without you ever knowing.
Wait, so just clicking a link could drain my bank account?
It highlights the importance of being cautious about the links you click,
Okay, yeah.
especially when you're logged into sensitive accounts.
That's scary.
Yes, CSRF exploits the trust your browser has in your logged-in state.
Okay, I think I need to sit down for a minute.
That's a lot to take in.
Okay, last but not least,
Okay.
we have clickjacking.
Clickjacking, yep.
This one sounds a little more visual, right?
Clickjacking manipulates what you see on a web page.
Okay.
Think of a transparent layer placed over a button.
Okay.
You think you're clicking play on a video,
Right.
but you're actually authorizing a purchase or giving away personal information.
So it's like those trick buttons you see online that say download but actually take you to a spammy website.
Kind of.
Except this is way worse because it could involve real actions on my accounts.
Precisely. Clickjacking plays on user interface trickery to get you to take actions you wouldn't normally take.
Right.
It preys on our assumptions about how websites should look and behave.
That's so sneaky.
It is.
Okay, so we've seen how these client-side attacks work.
Uh-huh.
It's pretty unsettling to realize how vulnerable we are just by browsing the web.
Yeah, it's a little unnerving.
But the paper also talks about how browsers are fighting back.
Right.
Tell me more about these built-in defenses.
This is where things get really interesting.
Okay.
Browsers are no longer just passive windows to the web.
Oh,
They're actively involved in security,
cool.
using a variety of tools and techniques to protect us from these attacks.
That's right. The browser superheroes,
Huh. Yeah.
also known as browser APIs.
Browser APIs, that's right.
Where do we even begin?
Let's start with Content Security Policy, or CSP.
CSP. Okay.
It acts like a bouncer for your browser,
Okay.
controlling what content is allowed to load on a web page.
That sounds powerful.
It is.
But how does CSP actually work in practice?
So it allows website developers to set very specific rules about what sources the browser can load content from.
Okay.
For example, they can restrict JavaScript to run only from the site's own domain,
Gotcha.
blocking any rogue scripts trying to sneak in from elsewhere.
So it's like a customizable security system for each website.
Yeah, you could say that.
That makes sense. Okay, what about sub-resource integrity, or SRI?
SRI. Yep.
That one always sounds a bit intimidating.
SRI focuses on the integrity of the files your browser downloads.
Okay.
It's like a digital fingerprint for every file, ensuring that what you get is the exact, unaltered file that the website intended to send.
So if someone tries to tamper with a file in transit,
Yeah.
SRI will catch it.
Exactly.
That's reassuring. But this all seems very code-heavy.
Yeah.
How do we as users even benefit from something like SRI?
Think about it this way. When SRI is working correctly, you're less likely to be hit with malicious code injected into a legitimate file.
I see.
It's a behind-the-scenes guardian protecting you from threats you might not even see coming.
I appreciate those behind-the-scenes guardians.
Me too.
Okay, let's move on to the next one.
Okay.
Trusted Types API.
Trusted types.
The name itself sounds like a good thing.
Yeah, this.
But I have to admit, I struggle to understand what it actually does.
You're not alone. This one's pretty technical. But essentially, trusted types ensures that any code interacting with your browser's core functions does so safely.
Okay.
It's all about preventing a specific type of XSS attack called DOM-based XSS, which is particularly difficult to defend against.
So it stops hackers from sneaking bad code into things like online forums so that our data stays safe.
Exactly. It adds another layer of protection right at the point of user input, where many attacks originate.
Okay, that makes a lot more sense.
Good.
I'm starting to see how these browser APIs work together to protect us.
Yeah, they're a powerful team.
What's next on our list?
Next up, we have permissions policy,
Permissions policy. Okay.
which is all about giving you, the user, more control over what a website can and can't access on your computer.
Okay.
Things like your location camera or microphone.
It's about time.
Hi.
So many websites just assume they can access everything.
It's true.
This gives us the power to say no thanks.
Exactly.
I like that. What else we got?
We have Web Authentication API, or WebAuthn.
WebAuthn.
It's being touted as the future of logging in,
Oh.
aiming to replace traditional passwords with secure cryptographic keys.
Hold on. So no more remembering a million different passwords.
the idea.
I'm already on board. But how does it actually work?
Instead of typing a password, you might use your fingerprint face scan or a physical security key to verify your identity.
Okay.
It's much more secure and user-friendly in the long run.
Right.
Because those keys are stored in your device.
Yeah.
And much harder for hackers to steal.
Okay. That's seriously cool.
It is.
I'm definitely looking forward to a passwordless future.
Me too.
All right, we have 2 more browser APIs on our list.
Okay.
CoreOS and the reporting API.
Chorus and reporting API, got it.
What do they bring to the table?
So CoreOS, or cross-origin resource sharing, helps browsers play nice with each other while still maintaining security.
Okay.
It sets boundaries for how websites from different origins can interact and share data.
Right, so it's like setting ground rules to make sure websites aren't sending data where it shouldn't be going. Gotcha. And then there's the reporting API.
Yes.
Which lets developers and security teams get insights into what kind of attacks are being attempted.
Uh-huh. It helps them stay one step ahead by collecting data on security violations and potential threats.
So it's like a security alarm system letting everyone know when something suspicious is happening.
You could say that it's a valuable tool for improving web security by providing real-time feedback on potential threats.
Right. So as you can see, your browser is packed with security features you probably never knew about.
Yeah, there's a lot going on behind the scenes.
I'm starting to feel a lot more confident about browsing the web knowing all of this is going on behind the scenes.
That's good to hear.
But there's another layer to the security story that we need to talk about.
Okay.
Web application firewalls, or WAFs.
WAFs.
They sound pretty serious. What are they all about?
WAFs are like security guards for websites.
Okay.
They sit in front of a website and inspect all incoming traffic, filtering out anything that looks suspicious or malicious.
So like a digital bouncer, but for the entire website.
Exactly. They act as a barrier between the internet and the web application.
Yep.
Analyzing traffic and blocking anything that doesn't meet the security rules.
That sounds pretty powerful.
It is.
Do they have like a playbook of known bad guys, or is it more sophisticated than that?
It's a combination of techniques that use rule-based protection, looking for patterns of known attacks like SQL injection or cross-site scripting attempts.
Okay.
They can also sanitize incoming data, removing potentially harmful content before it even reaches the web application.
So they're actively looking for those sneaky scripts we talked about earlier and scrubbing the data as it comes in.
That's one way to put it. They can also validate tokens, which are like secret codes that verify the legitimacy of a request.
Hmm.
This helps prevent CSRF attacks.
Okay, starting to see how this all ties together.
And all connected.
So we've got these WAFs playing defense against known attacks and scrubbing the data as it comes in anything else.
They can also manage bot traffic, identifying and blocking automated bots that might be trying to overload the website or exploit vulnerabilities.
Okay.
And some WFs have even evolved to monitor JavaScript behavior in real time.
Hold on, they're actually watching the code as it executes?
Exactly. By watching for unusual or suspicious JavaScript activity, they can block potential attacks as they happen.
Wow, that's impressive. It's like having code detectives constantly on the lookout for shady behavior.
I like that analogy.
Uh-huh.
It captures the essence of what WAFs are trying to do.
Yeah.
Prevent attacks before they can cause any harm.
The paper dives into some real-world examples of WAFs in action, mentioning big names like Cloudflare, Imperva Securi, and even AWS.
Familiar names.
Are these all companies that provide WAF services?
Yes. These companies offer various WAF solutions, each with its strengths and focuses.
Okay.
Cloudflare is known for its extensive network and DDoS protection capabilities. Imperva focuses on data security.
Okay.
Securi is popular for its website security platform. And AWS WAF, part of Amazon Web Services, is a cloud-based WAF service that integrates with other AWS services.
So there's a whole ecosystem of companies dedicated to building and deploying these digital security guards.
There is. It's a big industry.
That's pretty amazing, but I have to ask, are WAFs the be-all and end-all of website security?
WAFs are incredibly powerful, but they're not a silver bullet. They have their limitations too.
Of course, nothing is perfect.
Right.
What are some of the limitations we should be aware of when it comes to WAFs?
For starters, WAFs can't fix bad code on the website server. They can only analyze and filter the traffic coming in.
Right.
They can't rewrite the website's code from the outside.
That makes sense. It's like trying to fix a leaky faucet by putting a bucket underneath it.
Yeah.
You're not addressing the root of the problem.
Exactly. And there can also be performance impacts if WAFs are not implemented and configured carefully.
Okay.
We don't want our browsing experience to slow to a crawl because of overly aggressive security checks.
Right. It's all about finding the right balance between security and performance.
Exactly.
Oh.
Another challenge is that the threat landscape is constantly evolving.
Right.
Hackers are always finding new ways to attack. So WAF developers need to be constantly updating their tools and techniques to stay ahead of the curve.
It's like a digital arms race, always trying to outsmart the bad guys.
Precisely. And that brings us to one of the most exciting aspects of this whole discussion.
Okay.
The idea of WAFs and browser APIs working together,
Okay.
collaborating to create a more robust defense system.
Collaboration. Huh?
Collaboration, yeah.
Like the Avengers assembling to fight off an alien invasion.
You could say that by combining the strengths of browser APIs and WAFs, we can create a much more comprehensive and multi-layered approach to security.
I like it.
It's about leveraging the best of both worlds.
Okay. I'm officially intrigued.
Good.
Tell me more about this dynamic duo. How do they actually work together?
For example, WAFs can dynamically enforce things like content security policy headers. Remember that bouncer analogy?
Yeah, the bouncer at the website.
Well, the WAF can make sure the website is using a strict bouncer policy, even if the website developers forgot to set it up properly.
So it's like a backup bouncer making sure the rules are being enforced. I like it.
Exactly.
Yeah.
WAFs can also double-check that sub-resource integrity is being used correctly,
Okay.
adding an extra layer of confidence that the files your browser is downloading are safe and haven't been tampered with.
Like a second set of eyes making sure nothing slips through the cracks.
Yeah, that's a good way to put it.
That's reassuring. And here's where it gets really interesting.
Okay.
WAFs can tap into those browser reporting APIs, remember the security alarm system,
Yep.
while the WAF can listen to those alarms and get insights into what kind of attacks are being attempted in real time.
That's right. It's all about real-time communication.
Okay, that's pretty cool. The WAF is getting real-time intelligence from the browser itself.
Right. It's like having a direct line of communication between the frontline defense and the security command center.
This collaboration is starting to sound like a pretty powerful defense system. But is it all sunshine and roses?
Well,
Are there any challenges in making this collaboration work seamlessly?
not necessarily.
Okay, so browser APIs are awesome. They're doing all this work.
They're powerful for sure.
But are they like the end-all be-all of website security?
Well, they're powerful allies in the fight against client-side attacks, but it's important to remember that they're not a silver bullet.
Here's where it gets interesting, folks.
Uh-huh.
What are those limitations? What can't these browser superheroes handle?
One key limitation is that browser APIs primarily focus on the client side,
Okay,
meaning the user's browser and how it interacts with the website.
got it.
They don't have the same level of control or visibility into the server side where the website's code and data reside.
So it's like having a really strong lock on your front door, but leaving a window wide open in the back.
That's a great analogy. You
Yeah.
need a multi-layered approach to security with different tools addressing different aspects.
Got it. So browser APIs are great for protecting us from client-side attacks, but we still need other measures to secure the server side. What else should we be aware of when it comes to browser API limitations?
Another limitation is the dependency on client-side enforcement.
Okay.
Browser APIs rely on the user's browser to properly execute and enforce security policies.
Mm-hmm.
But not all browsers are created equal.
Right. We're assuming that everyone is using the latest and greatest browser with all the security features turned on, but that's not always the case.
Exactly. Some users might be using older browsers that lack certain features, or they might have disabled security settings for various reasons. This can create inconsistencies in protection depending on the user's browser and its configuration.
That makes sense. It highlights the importance of keeping your browser updated and being mindful of your security settings. But what about the websites themselves? Can't they do more to help protect users?
Absolutely. Websites play a crucial role in leveraging browser APIs. Effectively, security measures like content security policy and sub-resource integrity require proper implementation by website developers.
Right.
If they're misconfigured, they might not be effective at all.
So even with the best intentions, things can go wrong if the implementation isn't done right. It seems like there's a lot of responsibility on website developers to get this right.
There is, and it's not always easy. Keeping up with the latest security best practices and implementing them correctly can be a challenge, especially for smaller websites with limited resources.
Okay, so we've talked about the limitations of browser APIs, but the paper also introduces these things called web application firewalls, or WAFs.
WAFs, right?
They sound pretty serious. What are they all about?
WAFs are like security guards for websites.
Okay.
They sit in front of a website and inspect all incoming traffic, filtering out anything that looks suspicious or malicious.
So like a digital bouncer, but for the entire website.
Exactly. They act as a barrier between the internet and the web application, analyzing traffic and blocking anything that doesn't meet the security rules.
That sounds pretty powerful. Do they have like a playbook of known bad guys, or is it more sophisticated than that?
It's a combination of techniques that use rule-based protection, looking for patterns of known attacks like SQL injection or cross-site scripting attempts. They can also sanitize incoming data, removing potentially harmful content before it even reaches the web application.
So they're actively looking for those sneaky scripts we talked about earlier and scrubbing the data as it comes in.
That's one way to put it. They could also validate tokens, which are like secret codes that verify the legitimacy of a request. This helps prevent CSRF attacks.
Okay, starting to see how this all ties together. So we've got these WFs playing defense against known attacks and scrubbing the data as it comes in. Anything else?
They can also manage bot traffic, identifying and blocking automated bots that might be trying to overload the website or exploit vulnerabilities. And some WFs have even evolved to monitor JavaScript behavior in real time.
Hold on, they're actually watching the code as it executes.
Exactly. By watching for unusual or suspicious JavaScript activity, they can block potential attacks as they happen.
Wow, that's impressive. It's like having code detectives constantly on the lookout for shady behavior.
I like that analogy. It captures the essence of what waves are trying to do, prevent attacks before they can cause any harm.
The paper dives into some real-world examples of WAFs in action, mentioning big names like Cloudflare, Imperva Security, and even AWS. Are these all companies that provide WAF services?
Yes, these companies offer various WAF solutions, each with its strengths and focuses. Cloudflare is known for its extensive network and DDoS protection capabilities. Imperva focuses on data security. Security is popular for its website security platform. And AWS WAF, part of Amazon Web Services, is a cloud-based WAF service that integrates with other AWS services.
So there's a whole ecosystem of companies dedicated to building and deploying these digital security guards. That's pretty amazing. But I have to ask, are WAFs the be-all and end-all of website security?
WAFs are incredibly powerful, but they're not a silver bullet. They have their limitations too.
Of course, nothing is perfect. What are some of the limitations we should be aware of when it comes to WAFs?
For starters, WAFs can't fix bad code on the website server. They can only analyze and filter the traffic coming in. They can't rewrite the website's code from the outside.
That makes sense. It's like trying to fix a leaky faucet by putting a bucket underneath it. You're not addressing the root of the problem.
Exactly. And there can also be performance impacts if WAFs are not implemented and configured carefully. We don't want our browsing experience to slow to a crawl because of overly aggressive security checks.
Right. It's all about finding the right balance between security and performance. What else?
Another challenge is that the threat landscape is constantly evolving. Hackers are always finding new ways to attack, so WAF developers need to be constantly updating their tools and techniques to stay ahead of the curve.
It's like a digital arms race, always trying to outsmart the bad guys.
Precisely. And that brings us to one of the most exciting aspects of this whole discussion, the idea of Ws and browser APIs working together, collaborating to create a more robust defense system.
Collaboration, huh? Like the Avengers assembling to fight off an alien invasion.
Uh-huh. You could say that by combining the strengths of browser APIs and WAFs, we can create a much more comprehensive and multi-layered approach to security. It's about leveraging the best of both worlds.
Okay, I'm officially intrigued. Tell me more about this dynamic duo. How do they actually work together?
For example, WAFs can dynamically enforce things like content security policy headers. Remember that bouncer analogy? Well, WAFs can make sure the website is using a strict bouncer policy, even if the website developers forgot to set it up properly.
So it's like a backup bouncer, making sure the rules are being enforced. I like it.
Exactly. WAFs can also double-check that sub-resource integrity is being used correctly, adding an extra layer of confidence that the files your browser is downloading are safe and haven't been tampered with.
Like a second set of eyes, making sure nothing slips through the cracks. That's reassuring.
And here's where it gets really interesting. Waves can tap into those browser reporting APIs. Remember the security alarm system? Well, the Wave can listen to those alarms and get insights into what kind of attacks are being attempted in real time.
Okay, that's pretty cool. The Wave is getting real-time intelligence from the browser itself.
Right. It's like having a direct line of communication between the frontline defense and the security command center.
This collaboration is starting to sound like a pretty powerful defense system. But is it all sunshine and roses? Are there any challenges in making this collaboration work seamlessly?
There are definitely challenges.
Okay, so it sounds like Waves and browser APIs make a pretty awesome team.
Yeah, they complement each other well.
But I'm guessing it's not always easy to get them to work together perfectly, Rip.
You're right. There are definitely some challenges when it comes to integrating these two technologies. For one, the integration process itself can be quite complex and time-consuming. It requires a deep understanding of both Wave and configurations and browser API functionalities.
So it's not just a matter of slipping a switch and suddenly everything is working in perfect harmony.
Definitely not. It takes careful planning and implementation to ensure that the Wave and browser APIs are working together smoothly, complementing each other's strengths and not creating conflicts.
It sounds like it requires some serious expertise to get it right. What else should we be aware of?
Compatibility can also be an issue. Not all Waves are designed to effectively leverage browser APIs. There might be compatibility issues between specific Wave solutions and certain browser APIs, which can limit the effectiveness of the integration.
Right, it's like trying to fit a square peg into a round hole. It's not going to work as well as if everything was designed to work together from the start.
Exactly. And then there's the issue of limited use cases. While there's a lot of potential for Waves and browser APIs to collaborate, we haven't seen widespread adoption of this approach in real-world scenarios yet.
So it's still early days for this dynamic duo, and we need more examples of how they can be effectively used together to address specific threats.
That's right. We're still in the early stages of exploring the full potential of this collaboration, but the research is ongoing, and new use cases are emerging all the time.
That's good to hear. It sounds like there's a lot to be excited about when it comes to the future of WAF and browser API integration, but are there any other limitations we should keep in mind?
We also need to be realistic about the potential for a false sense of security. Just because you have a WAF and you're leveraging browser APIs doesn't mean you're completely invulnerable.
Right. It's not a magic shield that makes you immune to all attacks.
Exactly. Hackers are constantly evolving their techniques, and they're always looking for ways to circumvent security measures. So it's important to view WAFs and browser APIs as part of a layered defense strategy, not a standalone solution.
So it's about being realistic about the limitations and not getting complacent just because you've implemented some advanced security features.
Absolutely. And we also need to consider the potential performance overhead some of these security measures, especially resource-intensive ones like sub-resource integrity, can introduce performance bottlenecks that slow down the website's loading time.
Right, we don't want security to come at the cost of a smooth and enjoyable browsing experience. It's all about finding the right balance.
Precisely.
Right.
And there's also the challenge of measuring effectiveness. It can be difficult to quantify how much protection you're actually getting from these measures, especially when they're working in conjunction with each other.
It's not always a clear-cut yes or no answer. It's about understanding the nuances of the integration and how it impacts the overall security posture.
And we can't overlook the potential for conflicts with existing security measures. Implementing browser API-based security alongside existing WAF configurations and other security tools can lead to conflicts or unexpected behavior.
All right, so it's about making sure everything plays nice together and that you're not introducing new vulnerabilities by trying to layer on too many security measures.
That's a key point. It's important to thoroughly test and validate any integration to ensure that it doesn't create unintended consequences or weaken the overall security posture.
Right. We want to be sure that the cure isn't worse than the disease. So those are some of the challenges. But what about the future of this collaboration? Where do we go from here?
That's where things get really interesting. The paper poses a question that really got me thinking. What if browsers could automatically share information about attacks they've blocked with each other?
Okay, now that's a fascinating idea. Tell me more.
Imagine a real-time network of defense where browsers are constantly communicating, sharing data about malicious scripts, suspicious websites, and emerging attack patterns.
So, like a global immune system for the web where
Ah.
each browser contributes to the collective protection of everyone online.
Exactly. If a browser in one part of the world encounters a new type of phishing attack, it could instantly share that information with all other browsers, making them immune to the same attack.
That would be incredible. It would make it so much harder for attackers to exploit vulnerabilities because the knowledge of those vulnerabilities would spread so quickly.
It would be a game changer. It would shift the balance of power, making the web a much safer place for everyone.
But how realistic is that? Is there anything currently being developed that hints at this kind of browser-to-browser communication for security?
While widespread browser-to-browser communication for security is still largely theoretical, there are some promising developments in the area of federated learning.
Federated learning, that sounds familiar, but I can't quite place it.
It's a type of machine learning where models are trained on decentralized datasets without the data ever leaving the individual devices.
So, like, each browser would train its own security model based on its own experiences, but then they'd somehow share the insights from those models without actually sharing the raw data.
That's the idea. It's a way to learn from a global pool of data without compromising privacy.
That makes sense. It aligns with the growing emphasis on privacy-preserving technologies.
It's exactly. Now, applying federated learning to web security is still in its early stages, but there's a lot of research being done in this area.
It's exciting to think that someday our browsers could be working together behind the scenes, constantly learning and adapting to new threats.
It would be a major leap forward in web security, creating a more proactive and resilient defense system.
I'm all for that. But I also wonder, if we're talking about the future of web security, how does artificial intelligence fit into all of this?
AI is already playing a significant role in cybersecurity, and its influence is only going to grow.
We've touched upon it a bit with WAFs using machine learning to analyze traffic patterns and detect anomalies, but what other AI-powered innovations are on the horizon?
Well, imagine AI-powered tools that can analyze code in real time, identifying potential vulnerabilities before they can be exploited.
So, like having an AI security auditor constantly scanning your website's code for weaknesses.
That's one possibility. AI could also be used to develop more sophisticated and adaptive security systems that can learn from past attacks and predict future threats.
It sounds like science fiction, but it's becoming increasingly real.
It is. AI has the potential to revolutionize cybersecurity, but it's important to use it responsibly and ethically.
Right. We don't want to create a digital panopticon where AI is constantly monitoring our every move online.
It's about finding the right balance between security and privacy.
Which brings us back to the central theme of this entire deep dive, user empowerment.
As technology advances, it's crucial that users are informed and empowered to make decisions about their online security.
It's not just about relying on browsers and WAFs to protect us.
It's about understanding the risks, being aware of the tools at our disposal, and making conscious choices about our online behavior.
So things like keeping our browsers updated, being cautious about the websites we visit, and managing our privacy settings.
Exactly. It's about taking an active role in our own online security, not just passively relying on technology to protect us.
It's a shared responsibility between users, developers, and the companies that provide the tools and services we use online.
And that collaboration, I believe, is the key to creating a truly secure and trustworthy web for everyone.
Well said. This deep dive has been an eye-opening journey into the world of client-side attacks and the innovative ways we're fighting back.
It's been a pleasure exploring this complex landscape with you.
And to our listeners, we hope you've gained valuable insights into how you can stay safe online.
Remember, knowledge is power, and the more you understand about online security, the better equipped you'll be to protect yourself.
So stay informed, stay vigilant, and keep exploring the fascinating world of cybersecurity.
Until next time on The Deep Dive.